And I just hit record because you have so many people that are absent. I want to make sure I can give this to them. Okay, so I'm bouncing around from answering our questions and explaining the lab sheet that I gave you that I want ready to do on Tuesday when we come in. So the first thing we have to do for the lens is figure out the focal point. Why? Because if I go back to question number 25, what's the difference between a converging and a diverging lens? Distinguish between the two. Okay, so Henry, what did you say for that? What's the difference between a converging and a diverging lens?
A converging lens causes parallel rays to come together, and a diverging lens causes them to spread apart.
Very good. I love it. Excellent. Okay, converging causes parallel light to come together. And where do we get parallel light? From an object that is far away. So if we look at the light coming from an object that's far away, like the moon, as we had in our problem, right, it'll converge it to a single point called the focal point. But on a diverging lens, it'll take that parallel light and it spreads it apart from being on that focal point, as if it came from the focal point. So we would imagine that it came from that. It's still true that if I imagine this to be a circle, a full circle, that my center is, I didn't draw that very well, but the center is twice that focal length. So it's still geometrically true that your focal length is equal to 2 times your radius, or 1/2, I'm sorry. It's equal to 1/2 your radius. 2 focal lengths equals that. All right, so what I also want you to know about a converging, because this will be important in the lab, is what's true about it is it's thicker in the middle compared to the edges. So it is thicker in the middle compared to the edges. And a diverging is thinner in the middle compared to the edges. Okay, so it's thinner in the middle compared to the edges. So when we get in the lab, some of you are going to have a lens that's flat on one side and it curves out like that. It's still considered a converging lens because it's thicker in the middle. You might even have a lens that looks more like a fishbowl almost, where it's really thick in the middle compared to the edges, but it almost is like a circle, a sphere. Those would all be considered converging lenses. You can have a plano convex in the same way, something that looks like that, where it's flat on one side, but no matter what, if it's thinner in the middle compared to the edges, that is considered a diverging lens. Okay. All right, any questions on that so far? All right, so getting back to our focal length, the focal length is that distance to the point where that parallel light's going to converge. And in step 2, it tells you if I actually place an object, if I know where that focal point is, if I then actually put my candle at the focal point, then light comes from this candle in all different directions. And what the lens would do is it makes it come out parallel. So it actually would make that light travel really, really far. We had this discussion with the mirrors and your headlights and how we do that with the headlights. If we put the source at the focal point, it actually makes that light go out parallel and it travels very, very far. So in step 2 in the lab, once you determine what your focal length is, you then will put your candle at that focal length and you'll see you'll be able to project an image of that candle all the way across the room up onto the wall. Okay, so you'll project it up onto the wall. So you're just verifying where that is. What I want you to notice in this lab sheet as well is, see how I have step 1 and 2? You're going to get a second sheet that looks like this, where you're going to write your answers to everything. So it follows in the same order. Step 1, you follow these as your directions, but you're going to put your answers on this page. Okay, so you're going to get 2 sheets on Tuesday that look like this. The first one has all your directions of exactly what you have to do, and step those wherever you have to write answers, that's on this sheet. Okay. While you're doing that, and to answer our next few questions, let's talk about ray diagrams here. Actually, let me get rid of that and pull that back up again. Let's see, completed. I didn't want my drawings on there. All right. So to answer our next few questions out of the book, distinguish between a virtual image and a real image. How about Pierce? What do you got for that one? What's the difference between a virtual and a real image?
A virtual and a real image. A real images form when rays converge, while virtual images occur when rays diverge.
That is true. Yep. One works because of rays diverging, another is because of converging. That's correct. Which one can be projected onto a screen, Pierce? Which one can I like put onto a piece of paper?
A real image.
Good, a real image. Okay, so here's where what we're really doing in the lab. If we go back to our ray diagrams, there's only one place where you're going to get an image. Let's look at this one. So if I look at this first picture, my object is placed more than 2 of my focal lengths away, right? So remember, your focal length is, there's 1 focal length, 2 of them get you to the center. When you're beyond that, you're well beyond 2 times your focal length. So I put my candle, this is going to be your candle in the lab, is going to go right there. That represents your object. Okay, so going into the lab, step number 3 says place your object at a distance greater than 2 focal lengths away. So you're basically going to take your candle and you're going to put it 2 focal lengths away. You are then going to have a piece of cardboard, which is just an index card, and that's going to be your screen, and it's on the opposite side of the lens compared to the candle. You're going to take that screen and you're going to slide it back and forth and back and forth, okay? When you do that, if your screen is located, let me change my color here. If your screen is like located right here, you'll still get all this light on the screen, but it's not going to be focused. You're going to slide your screen in further, and there's going to be one place you're going to get a nice focused image of the candle, and it should be inverted. It should be reduced, and because it's real, you're going to be able to project it onto the screen. And you're going to do that here. Whoops. The next step that you take is to then put your object between 1 focal length and 2. So you're basically mimicking our ray diagrams. So then you're going to move your candle to twice the focal length in between the 2, and you're going to move your screen and you're going to see that the image changes. Those are real images that you're going to be able to project. These virtual images, as Pierce said, are the result of light diverging and spreading apart. You're still going to be able to see them, but you cannot project it onto a screen. So remember, all these images can be seen. Only real ones can be projected onto a screen, because I cannot take my index card and put it over here when my candle is located right here. All I can do is put my eye on this side, and with my eye, I'm going to actually see the image. I cannot project it onto a screen. So the difference between that real and virtual made from diverging, but cannot be projected onto a screen, real image made from converging light and can be projected onto screen. Both can be seen by our eyes. So our final question, number 28, what kind of lens can be used to produce the real and the virtual image? We go back to our ray diagrams. Only a converging lens can produce both, whereas the diverging lens only produces virtual. So real images can only be created by the converging lens, which matches our definition of a real image, and only the diverging. And when I'm inside the focal point of a converging, do I get virtual images? All righty. So what you're going to do in the lab, again, is move the object, which is your candle, at different places and see if what we drew on these ray diagrams makes sense. That's what you're going to see. All right, so that answers our questions in the textbook. See, those were those questions. Went over our problems and talked about the lab. Lots of stuff. Anybody have any particular questions?
No, ma'am.
Everybody still with me?
Yes, ma'am.
Yes, ma'am.
Yes,
We're also nice and quiet. Everybody loves virtual as teachers because it feels like better class control, but at the same time, I feel like, oh my goodness, I don't know whether you're listening or not, but I know you guys are. You're a great class. All right, so that was a lot of information all at one time.